In this video, I would like to talk about logarithms of base 10. So that will be shown as log with a base of 10, also known as the common logarithm. And some of the places where common logarithms are used are in, for example, the Richter scale, which is a measure of the magnitude of earthquakes, the pH of water, measuring decibels. And so when you see logs base 10, often you see that the base 10 is left out because it's so common. So you will just see the word log and you'll have the argument beside whatever value you're finding the log of. Now your scientific calculator is programmed for common logarithms. So take a look at your calculator and you'll probably see that there is a log button. And this button is for base 10 logs only. Let's try the calculator and we will find the logarithm of each of these values. Remember, this value here is called the argument. So we are finding the logarithm of these arguments. Notice that I did not include the base, so they're all base 10, which means you can use the log button on your calculator. So you just go ahead and you press log and you type in 1000. And you will see the answer. Log 1000 is equal to 3. Remember, this means what exponent do I put on 10 to equal 1000? Well, 10 cubed equals 1000. This is in log form and this is in exponential form. So what do you think log 10 is? What exponent is on 10 to equal 10? And that, if you look on your calculator, is 1. And, don't know why, but we have 1000 repeated there. We don't need that one again. Try log 75. If you think about this, guess what number it will be between log 10, well that's a 1, and log 100 is equal to 2, and 75 lies in between these two. So we should get a number between 1 and 2, and it's not 1.75. Check your calculator to see what log 75 is. And I get, if I go 3 decimal places, 1.875. Now, what range do you think the next one will be in? What value do we raise 10 to equal 6? If 10 to the 1 is 10, and 10 to the 0 equals 1, and our value is somewhere between 1 and 10, then this number must be somewhere between 0 and 1. So log 6, 0.778155125. We'll stop it at 3 decimal places for now. So those are common logarithms. They are by using the log button on your calculator, which is programmed for base 10. Now, if you take a look at that log button, there is also a second function of that log button. And if you look closely, you'll have your log button, and the second function of it is 10 to the x. So that's a reminder that this log button has base 10. What this does is the inverse function. It finds the common, because it's base 10, anti-logarithm, all right, the inverse function. It raises 10 to the logarithm, all right? So there's something called a common anti-logarithm. It is the value of 10 raised to a logarithm. Look at your log button on your calculator. Notice the second function of it is 10 to the x. When you find this value, you are finding a common anti-logarithm. Find the common anti-logarithm of the following values. And it will help to write out what you are doing. I can't say equals from here because 3 is not equal to what we're going to figure out. This is the logarithm. We will take our 10 and raise it to the logarithm 3 and find the anti-logarithm, which is 1000. Pause the video and try the other 3 with your anti-logarithm button. So in order to raise 10 to the power of 5, we have to use the second function button. We punch the log button. We put in the exponent 5 and hit the equals, and it is 100,000. 1 with 5 zeros. 10 to the power of 1.2. This will be between 10 and 100. So second function log 1.2. 15.849. I round it to 3 decimal places. And 10 to the power of 0.6. Second function log 0.6. 3.981. Okay, so that's common logarithms and common anti-logarithms. Just remember that with the word common, it means base 10. So the base, and if you see that the base is not written, it is assumed base 10. Next, we'll look at the very same topics, but with a different base. When the base is e, it is called a natural logarithm. Log base e is a natural logarithm. E is called Euler's number, which is a mathematical constant. It's something like pi, but a little less well known. E is approximately 2.718281828, and so on. And there is a process for finding E, but let's just know that it's approximately 2.718, in the same way that pi is approximately 3.14. So your scientific calculator is programmed for natural logarithms, and it is right beside your log key, and it is called the ln key, okay? Pronounced ln, not in. Okay, I think it's for logarithm natural, and these are only base e. So actually log base e of some value is equal to ln of the same value. Okay, so when you see ln, it just means log base e. Try some on your calculator. Find the natural logarithm for these following values using your ln key. So ln of 2.7183, which is a rounded version of e. Well, e raised to the what power equals e, and this is very close to 1. You'll notice on your calculator it's a little bit more than 1. That's because this isn't exactly e. E is really, it's an irrational number, so I can't really write it all down. But it is basically 1, okay? The ln of 240 is equal to 5.481. Many of these we have to use rounding. The ln of 1000 is 6.908. Remember, this is the exponent that must be placed on e to equal this argument. So if I convert back to exponential form, e to the 5.481 is equal to 240. And that's approximate because this was a rounded value. And e to the power of 6.908 is equal to 1000. So this is just the same thing but in exponential form. Ln 500. With the calculator, I just punch ln 500 and I get 6.2146, and then we get into really low numbers. So let's go 215. We've been doing 3 decimal places. So those are natural logarithms. It's a special name for a logarithm base e. Just like with common logarithms, there are also anti-logarithms. So this is called, if the base is e, it is called a natural anti-logarithm. And it is the value of e raised to a logarithm. So look above your ln button on your calculator, and you will see that it has e to the x. So that's a reminder that ln is base e because it's associated right there with the same value. So find the natural anti-logarithm of each of these values. Pause the video and give it a try. So natural is telling us that the base is e, and anti-logarithm means we must raise e to that power. So we're doing here e to the 3. And so I'll use second function, use the ln key, raise it to the power of 3 and equals. So second function ln, so now I have a place to put in the exponent on e, and we're raising it to the power of 3. That gives us 20.086. This value is called the natural anti-logarithm. The 3 is the logarithm. It's an exponent. The value when you use it is called the anti-logarithm. All right, this will be e to the 5. Second function ln, raise it to the 5, 148.413. E to the 1.2. Second function ln 1.2, 3.32 and 0. And e to the 0.6. Second function ln 0.6, 1.822. All right. So remember, I'm just repeat, this is a natural logarithm, and this is a natural anti-logarithm. How do we find logarithms for all other bases? Because we've seen how to find with base 10 and base e. There is a calculator button for those. And now we can use those buttons to find logarithms of all other bases. And I know that when we first started talking about logs, this is something that a lot of people try with the log button, and it doesn't work out unless it's base 10. So now we finally come to that formula. You can either use a ratio using logs or a ratio using lns, but don't mix them up. Both will work, so I've shown both formulas. So log base b of x can be found by taking the log base 10 of x and dividing it by the log base 10 of b. So let's see our example. We're going to find the log base 5 of 125. This, remember, represents an exponent. The exponent that 5 must be raised to equal 125. And if you know some of these things already, you'll predict that this answer is 3, but let's take a look at how it will work on the calculator. So with the calculator, we didn't punch in our log key, but we have to change the base. We'll make it base 10. So we take log of the argument divided by the log of the base. That can be keyed into the calculator exactly as you read it. Log 125 divided by log 5 equals, try that. And you should see that the answer is 3. Now, some calculators do have a button that says log base a of x, and that's rare, but if you have that button, then you can probably put in the 5 and the 125. But if you don't find that button or you don't know how to use it, then you can always just use the ratio of the log of the argument divided by the log of the base. You can do exactly the same thing with the ln button. So it will also work if I do ln 125 divided by ln 5. So here are a few more for you to try with your calculator. So because this is not log base 10, we have to use the ratio. So this will be log 27 divided by log 3. And that is equal to 3. Same with this. This is not base 10. So we will do log 32 divided by log 2. And that is 5. And this one will be log 147 divided by log 9. .271. And that's how you find logarithms of all other bases. So now we have seen log base 10. You use the log key directly. Log base e, you use the ln key. Log of all other bases, you must use the ratio of the log of the argument over the log of the base. And that's how we find logarithms.